Titration curve. So to understand a titration curve, we have to understand titration. This is an experimental technique that involves adding a gradual addition of a solution of accurately known concentration, which we call the standard solution, to another solution of unknown concentration until the chemical reaction between the two solutions is complete. So for an acid-base, this would mean neutralization. This would mean neutralization. So the titration curve, let's take a look at one, here tells us a lot about what's going on. So we can add a volume of a base to an acid which starts at a certain pH. And as we add acid, the pH starts to change, and we can measure that. And at this point, what we call the equivalence point, this is the point where there's enough titrant, which we call titrant in moles, that has been added. So this base here is called the titrant, has been added to completely neutralize the acid or base, what we call the subject acid or base. So this standard solution, or the titrant, is being added to this acid or base, and we are trying to figure out its equivalence point so we can find out when it's neutralized. And an endpoint is also part of the curve. This is where the indicator that tells you when this is an indicator that's going to a pH indicator. And this procedure, you're going to continue it until either the pH of the solution starts to level off, or there's a color change when you observe it using a pH indicator. So the endpoint is when the indicator changes color. So you know that the endpoint comes after the equivalence point. Now that we have that information, we also know that titration between a strong acid and a strong base is usually going to give you a pH of 7. So this is, with a strong acid and a strong base, we're going to have an equivalence point of pH 7. But the equivalence point does not always have to be 7. So when we have a weak acid, let's say a weak acid and a strong base, the equivalence point, we're going to have pH, and we're going to have, let's say, an acid, base NaOH. And we're going to add milliliters, so the volume, to this. So if we have a strong acid like this, a weak acid like this, the equivalence point is going to be closer here. And notice that its equivalence point is going to be more in the basic range, about 8 here. And this is almost a standard titration curve for a weak acid and a strong base. So this is the point, the equivalence point for there. And another important thing that the titration curve can tell you is at the half equivalence point, so for this, let's say that it's about here, this is going to be able to tell you the pKa. So the pKa is going to be, you can use that to see you can see what's happening here. So the pH is equal to the pKa at the half equivalence point. So a titration curve can give you the endpoint, the equivalence point, and for weak acid and strong base titrations right here can give you a half equivalence point, can give you the pKa as well. pKa equaling pH. So if you're doing the opposite, let's say you're adding an acid to a base, the same applies to both. So it would just start at a basic point instead of a acidic point, and then the steepest part of the curve would reveal the equivalence point.